Okay, guys, today we're going to start our lesson on, or really our unit on systems of equations. We're going to start with a system of two equations. So what we're looking at here is the graph of two equations. And what we do when we solve, we're looking for where the two linear lines intersect. So we would say that this point of 2, 5 is the solution. And we could check by putting 2 in for x, because it's an xy pair, and 5 in for y. So if I put 5 in for y, using that red equation, is equal to minus 2, because this minus is already sitting here in the equation, plus 7, we would get 5 is equal to 5. And to prove its solution, we'd have to use both equations. And the other equation that we're looking at is right here. So if we put 5 in for y, that would be 2 times 2 plus 1. And again, we would get 5 is equal to 5. So that would certainly work out. Determine whether these points are a solution to the given graph. Again, that's kind of what we just did without seeing the graph. We just need to test in both of these. So let's test first the point negative 1, 5. Keep in mind that negative 1 is the x and y is the 5. So testing the first equation, negative 5 is equal to 3 times negative 1 minus 2, so 1 over here. That would get us minus 5. Positive 3 times negative 1 is negative 3 minus 2. Now the signs are the same. Signs are the same. We add the numbers, keep the signs, so that one checks. Then we have to try for the second equation as well. Negative 5 is equal to negative 1. The first negative here is in the equation, that's this one, and then we're replacing x with negative 1. Minus 6. Two negatives become a positive. So we get minus 5. Again, it's equal to minus 5. Check. So we can definitely say that negative 1, 5 is a solution. Let's just change colors here. Let's try to see if 0, negative 2. Now the x is going to represent 0. Y is going to be negative 2. We'll work with the first equation here, substituting negative 2 in for y and 0 in for x. So negative 2 is equal to 3 times 0 minus 2. 3 times 0 is just 0. Nothing cancels out. So we wind up with minus 2 is equal to minus 2. That one checks. But it has to work for both equations if it's an actual solution. So we're going to test the second one. Now we're going to put negative 2 in for y here and 0 for x. So we get minus 2 is equal to minus 0 minus 6. That's just 0. Negative 2 does not equal negative 6. So we cannot say that 0, negative 2 is the solution. So that's what we're looking for when we're actually solving these. It's kind of a 4-step pace that we go through. We want to locate the variables with opposite or same coefficients. So this one has opposites right there. And this guy has the same. We'll work with opposite ones first. I'm just going to erase this so that we see exactly what we're looking for. When I say opposite, I do mean that it's the same variable, it's just one's positive, one's negative. And what you basically want to do, we're going to use the elimination problem, is add each of the common things together. So the x's we add, the y's we add, and then the numbers. So positive 3x minus 3x cancels out, which is great. Here, 4y plus 2y gets us 6y. Minus 6 plus 6 gets us 0. Now we can actually solve for y because we only have one variable. We're going to divide each side by 6. And we get y is equal to 0. Once we know what y is, you can pick either of the two equations to solve for the other variable. I'm going to use the top one. So 3x plus 4, and now we're going to substitute the 0 in, is equal to negative 6. So again, what I'm doing, I'm using this equation here. We're looking for the x. We substitute 0 in for y. Now we're going to solve for x. This is just going to get a 0, so we wind up with 3x is is equal to negative 6. Divide by 3. We get x is equal to negative 2. And then we're going to name the solution. And remember before, we're looking for the intersection of points. So we're going to name it as an xy pair, minus 2 and 0. Okay, so let's change colors again. Let's erase here just so we can see what's happening. Okay, so for this one here, I want these x terms to cancel out when I add them, which means one of them has to become negative. So the first thing I'm going to do is go ahead and multiply this top equation through by negative 1. We're going to take this negative 1, we're going to make sure we multiply it to each of the 3 terms in this equation. Basically, negative 1 is just going to change everyone's sign. So we're going to wind up with minus 2x plus y is equal to negative 7. Bringing just down the second equation, 2x plus 7y is equal to 31. Now when we go ahead and add these guys up, the x's cancel out. Y plus 7y is going to get you 8y. Positive 31, negative 7 gets you a positive 24. Dividing each side by 8. And we wind up with y is equal to 3. So once we know what our y term is, let's go ahead and box that. We know what that is. I'm going to use this either equation to solve for x. I'm going to use this top one just because the numbers are smaller. So 2x minus 3 is equal to 7. Adding 3 to both sides. 2x is equal to 10. Divide by 2. And we get x is equal to 5. Again, we want to name this as an ordered pair, as an xy term. Make sure you put the x first. Pay attention to which one you're looking at. 5 and 3. Okay, so for this video, these notes are 2-day notes. I'm just going to do the ones that I'm doing in class, not the your turn. Day after class, I will upload the answer keys so you can have the answers to both. All right, so the first thing I'm looking at is this problem. I can see that the y's would cancel out, so I don't need to manipulate anything. I'm going to go ahead and just add the two together. Minus 3x, positive 7x gets you a positive 4x. The y's would cancel when we combine. And then 8 and negative 12 gets us to negative 4. Dividing each side by 4, we get x is equal to negative 1. Now that I know my x term, we can choose either of these two equations. I'm going to choose the bottom one this time, just so you can see that it really doesn't matter which one you pick. 7, I'm going to substitute negative 1 in for the x because we know what x is now. I'm going to solve for y. 7 times negative 1 gets you negative 7. Adding 7 to both sides to isolate that y. And we get y is equal to negative 5. And then we just want to name our point, our solution, as negative 1, negative 5. Okay, let's look at another example. All right, I can see I've got these y terms here. I just need one to be negative and one to be positive. So I'm going to go ahead and multiply one of these equations through by negative 1. So I'm just going to rewrite the top equation because I'm not manipulating that one. I'm multiplying everything through by negative 1. So that means it's got to distribute to all 3 terms. A negative times a negative would get us a positive 2x. A negative times a positive here is going to get us negative y. And a negative times positive on the other side gets us negative 4. When I go ahead to combine by adding these two equations together, the y terms will cancel out. We get 3x is equal to negative 3. Dividing each side by 3. And I find x to be negative 1. Now that I know what x is, we're going to use one of these two equations here. definitely going to pick this top one. It's a lot easier of a problem to work with. So we're going to put -1 in for this x plus y is, whoa, hold on. That's kind of messy. Let's try this again. I don't know what happened there. -1 plus y is equal to 1. Want to isolate the y, so we're going to add 1 to both sides. And we get y is equal to 2. And again, if you wanted to ensure that you got your answer correct, you can check in both. Let's say we check the top problem. We'd say -1 plus 2. Does that equal 1? And yes, it does. So that one checks. On the second equation, -2 minus 1 plus 2, does that equal 4? A negative times a negative becomes a positive 2. And we do wind up with 4 is equal to 4. So you can check yourself. There's really no reason for any of these problems to be incorrect. And the last problem we're going to do here is this one. I need the x's and y's on one side, and this top problem doesn't have that. So what we're going to do here to this top one is we're going to subtract 7x from both sides. So let's just kind of rewrite the problem. If I subtract the 7x, let me rewrite the second equation first. So we have 7x plus y equals 9. Just rewriting this guy. On this side, we're subtracting the 7x. 7x and y are not like, so they cannot be combined. So we're going to wind up with this -7x plus 5y is equal to 3. Now I look at this equation here. The x's are opposites. So we're going to go ahead and cancel these guys out. You're going to have 6y is equal to 12. Dividing each side through by 6, and I found y to be 2. I'm going to pick one of these two equations to solve for the x. I'm going to use the second one. It looks a little bit easier to work with. So I'm looking for x. I'm going to substitute this 2 in for our y. It's equal to 9. Subtracting 2. And I get 7x is equal to 7. Dividing each side through by 7. And we get x is equal to 1. Now we want to write this as an ordered pair. Remember, it is an xy. So we want to make sure we're putting the x in for the x term. So it's going to be the point 1, 2. All right. The next video we'll talk about when you don't have opposites and having to multiply both equations. And I will see you next time.